Hi guys, how are you? How you doing? I think we will back today again to the same techniques of integration. I will try to go a little fast, but my objective is to let you understand everything. Okay. Now, if you have any question, just text me or email me, and we'll be more than happy to help you in any question you have. Okay. Let us go back to this problem because the last video stopped at this point and I don't recognize. Now at this point here, -7, if you follow me from the last video, -7 square root of 5 over 3, which is the dx. Dx equal this one, square root of 5 square root of 3, right? We took this out, cosine theta. 1 minus sine square theta is cosine theta. Okay, right? Then my final answer is -7 over square root of 3, right? -7, 5 square root of 3, right? Here. 5 cancel with 5, -7 over square root of 3. Cosine sine over 3 over 5x. Okay. Okay, look to this problem and see how it's in. Guys, I'm giving you 1 minute to look to what I did from the last time till now. Okay. In general, I can give you a general substitution for this. In general, integration of C, that's too big, I think so, right? I'm trying to give you a general form to help you just for these cases. Just, I don't want you to use it, just use it for this. C square root of what? A square, B square, X square dx, C over, right? A, right? Square root of, which is, whatever number you have here, you take the square root of that number, right? Whatever number you have there, here, right? You take the square root of that number. Look here, B here, 7, C over B, C over B, sine inverse, C over B, sine inverse, A over B of X. Okay, we don't need that. Okay, C over B, sine inverse, which is what we have here. Look here, C over B, -7 over square root of 3, -7 over square root of 3, sine inverse, square root of 3, square root of 5. Then C over B, 8, look here, 8, apply this rule, 8, what B? Now here, A equals square root of 4, which is 2, B square root of 16, which is 4, right? A over B, which is 4, sine inverse. A is what? 2 over what? 4 sine inverse of x plus c, which is 2 sine inverse, which is 2 sine inverse, which is 2 sine inverse of half x plus c, a over b. Okay, a over what? B. 3 square 3, 4 over, square 3, which is this guy over this, b over what? A, right? b over a, b over a, b over a, which is 4 over 2. 4 b over a, 4 over 2, right? 4, which is 2, right? b is 4 over 2 is 2. b over 2. If you don't want, but if the teacher wants you to show the work, you have to show the work as I did. Then my final answer for this guy is 8 over 4 sine inverse 2x plus c. That's my final answer for this guy. Okay, now let us skip this and go to the second, go back to our board and see a new trig substitution. See a new trig substitution. Okay, now we're done with this. Okay, now let us go to the second guy. Now when we have a squared plus b squared, when we have plus, not minus, when we have a plus, not minus, a squared plus b squared, x squared, x equal a over b times theta, then my substitution will be x equal a over b tan theta, and dx will be a over b secant square theta d theta. And my associated triangle, look here, okay, my triangle here will be, but my triangle here will be tan theta equal bx over a, which is here. I multiply bx, and because the tan obviously over adjacent, and this is my triangle. Okay, and the last side is this side. Okay, let us take examples, right? Example make everything easy. Integration of numbers, easy number, first 4 plus 9x squared dx. Now what we have to do, we have to, this plus, not minus, then we're going to use what? The rule, right? What's a? 4. A is 4, a squared is 4, b squared is 9, that means a is 2 and b is 3, and the rule is here, the rule a over b, right? Tan theta x equal 2 over 3 tan theta. Okay, if you need my advice, just get what? The triangle ready, because tan theta, get everything ready for you. 3x over 2 theta and 3x 2. And always the trick I told you, the last side is the same thing. If you add the 4 square plus 9x squared. Okay, good. I have everything left for me to find dx. Dx equal 2/3, right? Secant square theta d theta. Good. Now apply everything into the integration, and apply all what we did. This guy and this guy, right? Both of them in here. I'm gonna use a different color, green, just in case to make this difference. 4 plus 9. Now this guy, the x in blue, I'm gonna bring it blue. 2/3 tan theta square, and the dx I'm going to keep it red, right? Dx is 2/3 secant square theta d theta. Remember, derivative of tan is secant square. The derivative of tan is what? Secant square. Derivative of tan is secant square. Okay. Integration of 4 plus 9, because the square here, 4/9 tan square theta. You following me, guys? And here 2/3. I can take the 2/3 out. I want to take this 2/3. I don't need it here. Any constant, take it out of the integration, d theta. Now 2/3 integration of 4. 9 cancel with 9 plus tan square theta and secant square theta. We have 4 here. A small eraser, and here what? 4 tan square theta. And here secant square theta and d theta. Now this I'm gonna, okay, last step here, and then I'm gonna move to the top. And here the 4, you can take the 4 out of the integration, I mean the square root. I'm going to do it for you 2 steps. 1 plus tan square theta and secant square theta d theta. Then I'm going to move myself up. Okay. Okay, I'm going to bring my board here. Okay, then the last step is here. Good. Then the last integration is 2/3. And the 4 is here, becomes 2. And remember here, what color? I'm going to use this color. 1 plus tan square theta equal secant square theta. Remember, 1 plus tan square theta equals secant square theta. Then, the 4, the square root of 4 is 2. The square root of 4 is 2. And square root of what? Secant square theta and secant square theta d theta. Okay, I have 2 secant square theta. The first one, the secant square theta comes from 1 plus tan square theta. 1 plus tan square theta equals secant square theta. And the second secant square theta comes from the derivative of tan. Here, tan is secant square. And the 2 goes out. 4/3. And square root of this. Okay, secant theta. I'm going to do it, take my time in the first problem. I like to take my time for you guys. Secant cube theta, d theta. Okay, how I solve secant squared and secant cube. I should not do this step. I'm gonna erase it. Secant squared theta. Let me just erase this step. I'm gonna show you here. I will explain. I'm gonna have another YouTubes about sine and cosine. Sine and what? The powers for sine and cosine and tan and cotangent. Look to this. It's good in this way. If we remember that. Oh, I'm sorry. If we remember that, the secant square equal 1 plus tan, right? And right, secant square is 1 plus tan, and if we put 1 plus tan square, right? Secant, let us secant square, right? If we remember that secant square is 1 plus tan square theta, what we have to do at this step. One second, guys. Just I'm giving you the rule. I need you to follow this rule all the time. The rule saying for the secant cube, secant n, this, if you look to this guy, this 4/3 secant cube x, right? dx. Okay. I will give you a rule here to see it and apply it here. Now, integration of secant n mx dx equal secant, look, secant m minus 1 of x over m minus 1. You have to apply this rule, sine x plus n minus 2 over n minus 1. It should be given for you from your teacher, secant n minus 2 of x, n minus dx. Okay, then this depends on that, depends on this. This is 4/3, right? Then secant 3 becomes secant 3 minus 1 M3, secant square x over 2, which is the same, sine x plus what? N minus 2, which is m, I have m. Let me just m minus 2. Okay. Integration of m minus 2, which is 3 minus 2 is what? M is 3 in my case. 3 minus 2 is 1, and 3 minus 1 is 2 half. Secant x only. Secant what? X. Secant x dx. Okay. And integration of secant x, if you need it, guys, this is something different than here, a little advanced, is a given integration. This given integration. Then my final answer will be 4 over 6. I'm sorry, this we can cancel 1, 2. 2 over 3, right? Secant square x sine x. I need you to focus in this problem, and integration of secant ln, integration of secant is ln tan x plus secant x. Have absolute value in case if we have a negative plus c. Okay. I meant to give you this problem. I meant to give you this problem because some teachers, they give it to you and they, how the teacher, they give you this problem. This is my problem. Here, my beginning of explanation, right? When we have this form, we use tan theta. Tan theta equal b over x. I'll explain this. Then I give you this problem. The teacher will give you this problem, and he will ask you to start the problem, to start the problem as like this. Then he will give you the end integration, and to see if you can reach that integration. We did everything. You have to do everything. When you reach to this point, the teacher will be so happy from you at this point. You see here? Now after that you have secant cube. He will give you this rule, the rule secant m. For the cube, when you have c cube or c to the fourth or c to the fifth, you drop the degree down. Now, an integration of secant x is very well known, and that's your answer. And that's your what? Answer. Let us see an easier what? A problem. To solve another problem. Okay. Okay. Another example. Okay, 1 over this. Look here, when you have c over 1 a. Let me just solve the problem, okay? Then after that, we'll what? Okay. Then solve this problem. 4 over 9 plus 16x squared dx. Now you know this is different. This is in the denominator. That's different. Okay. A b over a over right. X equal a over b, right? 3 over 4 tan what? Theta. Then dx equal what, guys? 3 Let me just make this also red. Dx equal 3 over 4 secant squared theta d theta. I have all what I need. Go back to the integration. Integration 4 over 9 plus 16, and the x is 3, right? Over 4 tan theta. I'm sorry, I'm going to do the square later on. Check. Tan theta square. And this is red, and this is dx is what? 3 over 4. Okay, secant square theta d theta. Okay. Okay, now here, organize it. 4 over 9. Look here, we have here 2 square and 4 square. These cancel each other, 16, right? And here left, plus 9 tan square theta. And here, 3 over 4, I can take it out, and this secant square theta. Now, also the 4, this 4, I want to leave it there, 3 over 4, and this 4, and this 4, and this 4 from here, and here, 1 over 9, 1 plus tan square theta, and secant square theta d theta. Secant square theta d theta. Okay. Okay. And remember one plus tan square theta equal what, guys? Secant square theta. Remember this. 1 plus tan square equals secant square. That means all this guy cancel with this guy. Because 1 plus tan square theta equal what? Secant square theta. If you need, I'm going to do 2 steps. If you need. Okay, you can do it like this. Secant square theta over secant square theta. If you need me to do 2 steps. Because, and we have 9. I'm talking about this guy only. I'm talking about what? This guy only. I'm talking about this guy only. It's the same as this guy. Because this equal to that. Now, we end up with this. We end up with let me just finish this problem. Okay, finish it quickly. Integration 12, right? I'm gonna forward go for 3 over 4 small 3 over, right? 3 only, and over 9, 3 over 9, and here what we have, secant integration of theta d theta, right? Which is 3 over 9 theta plus c, and theta is tan inverse of what here? Theta equal tan inverse, right? Theta equal tan inverse 4x over 3, right? Tan inverse 4x over 3. Theta is 3 over 9 tan inverse 4x over 3, right? 4x over what? 3. Okay. Thank you guys. Plus C. I don't want to bother the C because there's some point you're taking. Thank you guys and have a nice day.